Hi students, welcome back to our new class. In this class, we are going to study about spherical mirrors ray diagrams, that is chapter 1 for SSC board, and even it is there for Cbse students also. Rules to draw ray diagrams of spherical mirrors. So what are the different rules to be followed while drawing ray diagrams using spherical mirrors? How the incident rays will behave and how the reflected rays will behave. Okay, how we have to draw the ray diagrams. Before having idea about drawing of ray diagrams, we should know the rules pertaining to the ray diagrams in case of spherical mirrors. Rules to draw ray diagrams. In this first one is, we'll be discussing about behavior of the rays, incident rays. If the incident ray is propagating in one particular manner, how the reflected ray will behave in case of both concave and convex mirrors. First, I am talking about rule 1. So, in case of concave mirror, this one, if you consider, in case of concave mirror, if you consider, this is a and this is a pole of the mirror, and it is called focus, and it is center of curvature. So, if the incident ray is parallel to principal axis, if the incident ray is propagating and it is parallel to principal axis, if the incident ray is parallel to principal axis, the incident ray is propagating like this. It is parallel to principal axis. After reflection, it passes through focus. If the incident ray, if I consider this one as I and this is R, if the incident ray is parallel to principal axis, after reflection, it passes through focus. This is the first rule. In rule 1, okay, if the ray is, whatever may be the ray, if it is parallel to principal axis, so the incident ray is rays, if the incident ray is parallel to principal axis, okay, after reflection, it passes through focus. So this is a first rule. Now, second one. Second one. Now, rule 2. If the incident ray is, now, if this is a concave mirror, you know, this is what called as a pole of the mirror, and it is called focus, it is center of curvature. If the incident ray passes through, if the incident ray passes through focus, after reflection, it is parallel to principal axis. If the incident ray is passing through focus, it passes through focus, after reflection, the reflected ray will be parallel to principal axis. This is second rule. Now, if you want, please write down. I will dictate. If the incident ray is passing through focus, after reflection, it is parallel to principal axis. I hope you understood how the ray behaves if it passes through focus. If it passes through focus, after reflection, it is a parallel to principal axis. Now the third one, that is rule 3. Rule 3. We'll be talking about rule 3. So in this concave mirror, and as usual, this is a pole of the mirror, it is called focus, and it is center of curvature. So if the incident ray is, okay, coming from center of curvature, the incident ray is passing through center of curvature, and the reflected ray bounces back in the same path. This is incident ray and it is reflected ray. If the incident ray is passing through center of curvature, and the reflected ray will be bounces back in the same path. Okay, So this is a rule 3. If the incident ray is passing through center of curvature, reflected ray bounces back in the same path, that is through center of curvature only. Okay, this is a rule 3. Okay, I hope you understood this. Next one, now we are having a rule 4. Mostly in state textbooks, you won't be finding this particular 4th rule, but I am explaining about this 4th one. So there is this is concave mirror, and it is called as a pole, and it is focus, and it is center of curvature. If the incident ray is passed obliquely onto the pole of the mirror, if the incident ray is passed obliquely onto the pole of the mirror, it reflects back the same angle from the other side of the principal axis obliquely. Okay, this is incident ray, this is reflected ray. If the incident ray is passed obliquely onto the pole of the concave mirror, it reflects back with the same angle from the other side of the principal axis, that is obliquely only. Is it clear? This is incident ray and it is reflected ray. So if it is passed obliquely onto the pole of the mirror, it reflects back from the other side of the principal axis with the same angle, that too it is obliquely from the other side of the principal axis. This is a rule 4, and you won't be finding this in state textbooks, but it is there. Even I think it is there in Cbse and even ICSE books. Okay, so this is also very, very important rule to remember. It is much useful when you are drawing virtual images, and even both in case of concave and convex mirrors. Next, rules pertaining to convex mirror. In case of convex mirror, how the rays will behave. Next one is rules related to convex mirror. How the rays will behave, okay, when they are going to incident onto the reflecting surface of the convex mirror. Now this is a convex mirror, and it is what called as a pole, and it is a focus, and it is center of curvature. So first rule, now in case of a convex mirror, I'll be talking about rule 1, that is for a ray which is parallel to principal axis. If the incident ray is parallel to principal axis, after reflection the ray diverges. If this divergent ray, if you extend back forth, it appears such that it is coming from where? It is coming from focus. So this is incident ray and it is reflected ray. You know, convex mirror is a diverging mirror. If the incident ray is parallel to principal axis, after reflection the reflected ray diverges and extend this divergent reflected ray back forth by using a dotted lines. It appears such that it is coming from focus. This is a rule 1 for convex mirror when you are drawing the ray diagrams. If the incident ray is parallel to principal axis, after reflection it diverges. If this divergent extend back forth, it appears such that it is coming from the focus. The imaginary line will meet at focus, and this reflected appears to be coming from focus. This is a rule 1. That is, if the ray is rule 1 in the sense, if the ray is parallel to principal axis, if the incident ray is parallel to principal axis, then only this will be applied. Is it clear? Now we'll be talking about rule 2 for convex mirror. Now rule 2 for a convex mirror. So you know well, this is a convex mirror, and it is a pole, and it is a focus, and it is center of curvature. Now if the incident ray is passed with a certain angle onto the focus, appears to be in the direction of focus, after reflection it diverges, and this divergent reflected ray is parallel to principal axis. Remember this. Okay, if the incident ray is projected or passed in the direction of the focus, After reflection, the reflected ray, okay, is parallel to principal axis, and this is considered as a imaginary line. Is it clear? With a certain angle in the direction of the focus. After reflection, it is parallel to principal axis, divergent reflected. This is incident ray and it is reflected ray. This is a rule 2 for what mirror? Convex mirror. Next one, we are having a rule 3 for convex mirror. Now, rule 3 for convex mirror, that is, this is a convex mirror and it is pole of the mirror and it is focus and it is a center of curvature. Okay, so if the incident ray is passed with a certain angle, that is 90 degrees with respect to reflecting surface, and appears to be passing through center of curvature. Okay, and if the ray is passing through center of curvature and the reflected ray will bounce back in the same direction, that is the same angle, in the same direction. This is incident ray, this is reflected ray. If the incident ray is passed on to the in the direction of the center of curvature, appears to be going in the direction of center of curvature, the reflected ray bounces back in the same direction, okay, in the same with the same angle in the same direction, reflects back in the same direction, and if you extend back forth the dotted lines, it appears that it is passing through center of curvature. See, now this is a rule 3. Okay, next one, the last rule in case of a convex mirror, that is rule 4. We are going to discuss about rule 4. Now, 4. Now, this is a convex mirror and it is called as a pole and it is a focus and it is center of curvature. If the incident ray is passed with a certain angle obliquely onto the pole of the convex mirror, okay, the reflected ray bounces back with the same angle from the other side of the principal axis. Reflected ray, this is incident ray, this is reflected ray. If the incident ray is onto the pole of the reflecting surface of the convex mirror, the reflected ray bounces back from the other side of the principal axis with the same angle, that is obliquely only. This is incident ray, this is a reflected ray, and this is a pole of the mirror. Incident ray, reflected ray, the same angle from the other side of the principal axis, that is also obliquely only. Is it clear? So these are the rules pertaining to both concave and convex mirrors, which you have to follow how the rays will behave when you're drawing the ray diagrams of both concave and convex mirrors. I think I clarified everything very clearly. I hope you all understood this. Okay, if you understand my explanation, please subscribe, like and comment. Thank you.